Hello everyone, welcome to Chemazon-Complete Chemistry. So in today's video, we are going to see one of the very important topics of organic reaction mechanisms, that is formal charge. So what is the importance of finding a formal charge of a particular structure? So it is going to be helpful for writing resonance structures, for writing Lewis structures, and for writing any organic mechanism. We must know how do we assign a formal charge by using a structure and also by using the formula. Okay, and these are some of the structures where we are going to see how do we get these formal charges. Now, before understanding the method to assigning formal charge, let us first understand what is the meaning of a formal charge. So what is formal charge? Formal charge is the difference between an atom's valence electrons. Valence electrons means electrons present in the outermost shell. Electrons present in the outermost shell is called as a valence electron, and the electrons around a particular atom in the Lewis dot structure. Okay, so now let us understand how do we exactly find out the formal charge. So now, while finding out the formal charge, we will come across three different cases. Case one is when the number of electrons around the atom, number of electrons around the atom is same as the number of valence electrons. Number of valence electrons. If this is the case, then what is going to be the formal charge? The formal charge is going to be zero, which means there will be no charge. Formal charge is zero or no charge will be assigned on the atom. For example, let's say we have ammonia. Okay, nitrogen has how many valence electrons? 1s2, 2s2, 2p, 3. Atomic number of nitrogen is 7. So how many valence electron? Outermost shell is second orbit. So 2 plus 3, 5. So there are 5 valence electrons. So now what we have to do? We have to count 2, 3, 4, and 5. You can see the number of electrons is exactly same as the number of valence electrons. So what will be the charge? There will be no charge, or formal charge is 0. Okay, or we can say zero charge. Okay, this was the first case. Second case is if the number of electrons around the atom, okay, in a Lewis structure is less than the number of valence electrons. Okay, in this case, what is going to be the formal charge? The formal charge is going to be positive. Formal charge is positive. Now we have to understand when we get a positive charge, we get a positive charge when an electron is removed. Okay, when an electron is removed from a neutral atom. When an electron is removed from a neutral atom, then we give that particular atom a positive charge. Let us understand with the help of an example. Again, let us take nitrogen. Okay, here nitrogen is forming 4 bonds. So how many electrons are there around nitrogen? One more important thing is, out of the 2 electrons forming the bond, you have to count only 1 electron because nitrogen is contributing only 1 electron. So 1, 2, 3 and 4. So total 4. So 4 is what? It is less than the valence electrons, that is 5. So the number of electrons that is less, that much will be the formal charge. If it is 3, then the formal charge is plus 2. Here it is 1 less than the valence electron. So the formal charge will be plus 1. Okay, so here what will be the formal charge? The formal charge will be plus, like this, plus 1. Okay, and the last case is when the number of electrons around the atom, in a Lewis structure is greater than the number of valence electrons. Okay, if this is the case, then what will be the formal charge? the formal charge is going to be negative, will be negative. For example, suppose I write here fluorine. Okay, around it there are these many valence electrons. So we know for halogens there are how many valence electrons? 7. 1s2, 2s2, 2p, 5. For fluorine atomic number is 9. So how many valence electron? 2 plus 5, 7. Here if you count 2 plus 2, 4, 4 plus 2, 6, 6 plus 2, 8. That is 1 electron is more as compared to the valence electron. So if 1 electron is more, you will add the charge minus 1. If 2 electrons are more, then we add the charge minus 2. So here what will be the charge on fluorine? Here it will be minus. Okay, that is how do we get that it is a negative charge? Because when the electrons are added, then only we give it, then an atom acquires a negative charge. When an electron is added to the neutral atom, it gets a negative charge, negative formal charge. Okay, this was the last case where the total electrons around the atom are greater than the valence electrons. Okay, so now let us see the second method, that is using the formula. So what is the formula for calculating the formal charge? Formal charge is equal to number of valence electrons minus number of bonding electrons, that is the electrons that are forming the bonding electrons divide by 2 minus the number of lone pair electrons, or it is also called as non-bonding pair electrons, because lone pair does not participate in bonding. Non-bonding pair electrons. Now it is very important. Lone pair means suppose there is one lone pair, then the electrons you will count is 2. You have to count the electrons, not the lone pair. If there is one lone pair, 2 electrons. 2 lone pair, then 2 into 2, 4 electrons. Okay, you have to count the electrons, not the pair. Similarly, here also, if it is forming one bond, then it is equal to 2 electrons. Okay, so this is the formula. Number of valence electron minus number of bonding electron divided by 2 minus number of lone pair electrons or non-bonding pair electrons. Now, let us apply this on some examples so that we can understand better. Okay, oxygen. What is the valence electron for oxygen? We had seen just now. Oxygen, it is 6. Nitrogen, we had seen it is 5. And halogen, that is Br, it is how much? 7. Okay, so now we can find out oxygen, how many electrons are there around it? 2 plus 2, 4, 4, 5 and 6. Okay, so it is same as the valence electron. So what will be the formal charge? No charge or zero formal charge. Okay, now let us see the second one. Here how many electrons are there? 2, 3, 4, 5. So 5 is less than the valence electron. So what will be the charge on this? It will be a plus charge, plus 1 charge. Next one here 2, 4, 6 and 7. Now 7 is greater than 6. So what will be the charge? OH minus. Minus charge on oxygen. Now nitrogen, here there is how many electrons? 1, 2, 3 and 4. So 4 electrons around nitrogen. 4 is what? It is less than 5. So what will be the charge on nitrogen? Plus 1. Okay, similarly here if we see 2 plus 2, 4, 5 and 6. So it is same as the valence electron. So there will be no charge. Here next one 2, 3, 4 and 5. Sorry, here it will be 2 plus 2, 4 plus 2, 6. 6 is what? 6 is greater than 5. So here the charge will be minus 1. Here 2, 3, 4, 5. Here it is same as the valence electron. So here there will be no charge. And last one Br 2 plus 2 4, 4 plus 2 6, 6 plus 2 8. 8 is greater than 7, so negative charge. Okay, so this is how you find out the formal charge using the structure without using the formula. Okay, now let us see how to find out the formal charge using the formula. Okay, of the underlined atom, we have to find out for the underlined atom. Let's say this atom is O1 and this is O2. So for O1, how much is the valence electron on oxygen? Oxygen valence electron is 6 minus how many bonding electrons? So here there will be two lone pairs, okay? Minus how many bonding electrons? There is only, this is one bond and this is another bond. So 2 twos are 4. Divide by 2 minus how many lone pairs are there? 2 lone pair, 2 into 2, 4 electron. Lone pair electrons is 4. So 6 minus 4 divided by 2 is 2 minus 4. Okay, 4. So 6 minus 2, 4, 4 minus 4 is 0. So there will be no charge on this oxygen, O1. Now let us see O2. O2, there are how many valence electron? Oxygen valence electron is 6 minus bonding electrons. There is only one bond formed. So 2 divided by 2 minus, there are how many lone pair or non-bonding electrons? 2 plus 2, 4 plus 2, 6. Okay, so here it will be 6 minus 1 minus 6. So 6 minus 1 is 5, 5 minus 6 is minus 1. So what will be the charge on this? Negative. Okay, so for by using the formula and by using the structure, we will get the same answer. Let us see for this nitrogen. Okay, nitrogen, how many valence electron? 5 minus how many bonding electrons? 1, 2, 3, 4, 5, 6, 7 and 8. So 8 bonding electron divided by 2 minus how many lone pairs? 0. Okay, so 5 minus 8 divided by 2 is 4. 5 minus 4 is 1. Okay, so what will be the charge on this? It will be plus. Okay, also if by structure, if we see how many valence electrons are present, how many electrons are present? 1, 2, 3 and 4. 4 electrons, that is less than the valence electrons. So again the same result, we will give a positive charge. Now let us see this last example. Na. Okay, Na. Here if we see, first of all, how many valence electrons are there in nitrogen? 5. So 2, 3. Okay, first of all, valence electron minus how many bonding electrons are present? How many bonds are present? 1, 2, 3 bonds. So how many electrons are present? Bonding electron 2 plus 2 plus 2, that is 6. Divide by 2 minus how many lone pair is present? 2 lone pair electrons. So 5 minus 3 minus 2. 5 minus 3 is 2. 2 minus 2 is 0. So for Na, there is no charge. Similarly, let us find out for Nb. Nb will be how many valence electrons? 5. How many bonding electrons? How many bonds are formed? 1, 2, 3 and 4. 4 bonds. So 4 into 2, 8 electrons. 8 divided by 2 minus how many lone pair are present? 0. Okay, so 5 minus 8 divided by 2, 4. So answer is plus 1. So positive charge on Nb, that is plus 1. And last is Nc, that is valence electron is 5 minus how many bonding electron? 1 and 2. 2 bonds are formed. So 2 to the 4. 4 divided by 2 minus how many lone pair? 2. So 2 to the 4 lone pair electrons or non-bonding pair electrons. 5 minus 2 minus 4. So 5 minus 2 is 3. 3 minus 4 is minus 1. So the charge on Nc is minus 1. That is like this. Okay, so here we come to the end of this video. I hope you have understood the concept of formal charge. What is a formal charge and how do you calculate using the structure as well as using the formula. Thank you so much.